So the next topic is top-down parsing in Unit 2 in compiler design. So what is top-down parsing? So it is a parsing technique in syntax analysis, right? So we have two types of techniques here in syntax analysis. That is, first one is top-down parsing and the second one is bottom-up parsing. So a program which performs the syntax analysis is called a parser. So a syntax analyzer which takes as tokens as input, as we have discussed, which is taken as input and it is generating the parse tree. Okay. So in that, how it is in which way it is generating the parse tree, or it is from top down or bottom up parsing. So two techniques we are going to discuss. So in top-down parsing, when the parser starts constructing the parse tree from the start symbol and then tries to transform the start symbol to the input, it is called a top-down parsing. Okay. So we have a types in top-down parsing called recursive descent parsing and backtrack. Okay. So what is recursive descent parsing here? It is a common form of top-down parsing. It is also called a recursive as it uses recursive procedures to process the input. So recursive descent parsing suffers from backtracking. So what is backtracking? It means the if any one derivation of a production fails, then the syntax analyzer restarts the process using different rules of same production. Then the technique may process the input string more than once to determine the right production. So therefore, a parser using a single symbol look ahead method for in and top-down parsing without backtracking is called LL1 parser. In this following section, we will also use an extended Bnf notations. We'll see what is that. So in which some regulation expressions operators are to be incorporated. So in syntax expression defines sentences of the form, or a syntax of the form. It defines the sentences that consist of a sentence of the form followed by a sentence of the form followed of the form. A syntax of the form defines the 0 or 1 occurrence of the form. So this is nothing but recursive descent, which defines the 0 or more occurrences of the form. These are the forms of recursive descent parsing. So a usual implementation of LL1 parser is to initialize the data structures, get the look ahead token by calling its scanner routines, and call the routine that implements the start symbol. In this we have first and follow. Okay, so how to find first and follow? To compute the first of x for all the grammar symbols x, apply the following rules until no more terminals or we can be added to any first set. So if x is a terminal, then first of x is x of first of x is called x. So if x implies e, it is a production, then add e to the first of x. Okay. So if x is non-terminal and x implies y1, y2 up till yk, it is a production, then place a first of x if first of I, a is in first of yi, then the e is in all of first of yi to first of yi minus 1. So that is y of 1, y1 to yi, that is implies e. So if e is in first of yj, so for all the j equal to 1 to k, then add e to first of x. So for example, everything in first of yj is surely in first of x, right? So if y1 does not derive e, then we add nothing more to first of x. But whereas y1 is greater than or equal to e, then we add first of y2. So like this we are going to construct. So to compute the first of a for all the non-terminals a, then apply the following rules until nothing can be added to any follow set. So place dollar in follow of is where S is in the start symbol and S dollar in the input right end marker. So if there is a production called A implies ABS, so that is terminals and non-terminal, where first of S accepts E is placed in follow of B. So if there is a production A implies AB or a production A implies ABS, so first of S is contains E, right? First of S contains E. Then everything in follow of A is in follow of B. So consider another example. So consider the following example to understand more about first and follow concept. Okay. So here we have the productions E implies TE and E dash implies, these are the productions augmented grammar. Okay. This is also called augmented grammar. Okay. So we'll see what is augmented grammar in the other sessions. So then first of E is first of T. So first of E is first non-terminal, here is first of T, right? So first of T is equal to first of S. So first of T equal to, here first of T equal to first of S. So first of F is first of ID or left parenthesis. So we have F implies left parenthesis E here. So first of F is left parenthesis or ID here, right? So first of E dash is plus here. Yes, plus first of E dash is plus or E here. So or else we have E symbol here. So we have to take first of E dash plus or E. Again compute first of T dash. So first of T dash, here we have star or E, right? So here star or E. So follow of E is equal to follow of E dash. Follow of E dash means here follow of, after follow we have E dash. So follow of E dash is having closed parenthesis. Follow of E dash is nothing but follow of E followed by closed parenthesis. That is dollar symbol is accepted state also we have to take. So follow of T is equal to follow of T dash. It is nothing but follow of T dash. Follow of T dash is what we have, plus and closed parenthesis and dollar symbol. Again follow of F is here we have T dash, right? So follow of T dash is first of T dash, that is star and closed parenthesis and accepted state and place. Yes. So for example, we have ID and left parenthesis are added to first of S. Then the by rule 3 in definition, we have a first with I equal to and 1 in each case. Then since first of ID equal to ID, then first of left parenthesis is left parenthesis. It is according to rule by 1. Then by rule 3, we have I equal to N, the production T implies FT dash, then it implies that ID and left parenthesis belongs to first of T also. So to compute follow, we put dollar symbol in follow of E by rule 1 for follow. So by rule 2, we have applied the production F of F implies E in open and close parenthesis. Right parenthesis is also in follow E. So that is a, by rule 3 we have applied E implies E dash dollar and that parenthesis is also follow of E dash. Clear? So how to construct in predictive parsing tables. So after constructing augmented grammar, after uh, calculating first and follow of the predictions. So for any grammar, we have to take the following algorithm can be used to construct the predictive parsing table. Okay, so input as grammar, then the output as parsing table. So first method, for each prediction, A implies A of the grammar, do again repeat the steps 2 and 3. So first of A, follow of A we have seen already. So what is LL1 grammar here? So the above algorithm, this algorithm can be applied to any of the grammar G which produces a parsing table M. So for some grammars, for example, if G is left recursive or ambiguous, then M will have at least one multiply defined entry, right? So a grammar whose parsing table has no multiply defined entries, it is said to be a LL1 grammar, right? So it can be shown that the above algorithm can be used to produce for every LL1 grammar G a parsing table M that passes all and only the sentences of G. So LL1 grammars have several distinctive properties. So these grammars, LL1 grammars have several distinctive properties. No ambiguous or left recursive grammars can be LL1. So there remains a question of what should be done in case of multiply defined entries, right? So one can say the solution is to eliminate all left recursion and left factoring, which is hoping to produce a grammar which will produce no multiply defined entries, which is in the past tables. So unfortunately, there are some grammars which will give an LL1 grammar after any kind of alteration here. So in general, there are no universal rules to convert multiply defined entries into a single valued entries without affecting the language recognized by the parser. So the main difficulty is using predictive parsing is in writing LLL grammar is for the source language such that we have a predictive parser can be constructed from a grammar. So although we have a left recursion elimination and left factoring are easy to do, but they make the resulting grammar hard to read and difficult to use the translation purposes. So to alleviate some of these difficulty, a common organization for a parser in a compiler is to use predictive parser for controls. So constructs and to use operator precedents for expressions. However, we have if an LR parser generator is available, so one can get all the benefits of predictive parsing and operator precedents automatically. So how we have error recovery methods in predictive parser. So the stack of a non-recursive predictive parser makes explicit the terminals and the non-terminals that the parser hopes to match with the remainder of the input. So we shall therefore refer to symbols on the parser stack in the following discussion. An error is detected during predictive parsing when the terminal is on the top of the stack which doesn't match the next input symbol. So on when non-terminal A is on the top of the stack, where A is the next input symbol and the passing table entry M of A comma A, which is empty symbol. So this is nothing but LR passing here. The L is of the left to right scanning of the input and the R is the constructing rightmost derivation in reverse. So we can see all these things in bottom up passing. Okay, so in top down we have recursive descent passing and LL1 passing, but in the bottom up we have the shift reduce passing and LR passing. So all these things we can discuss in bottom up passing techniques also. So this is all about top down passing. Thank you for listening.